We will discuss the radius program. The radius also corners removing operation, in which we remove the sharp corners like this. These are the radius. This is the drawing of the radius component. Observe the drawing. After that, mention the points of this drawing. The points start from the origin. The origin point is P1. Next, go to the arc start point. That point is P2. The arc endpoint is P3. The next point is P4. Again arc. This arc's start point is P5. The arc endpoint is P6. The next points are P7, P8. The last point is P9. Now we will discuss the motion commands and values of the points. The P1 point is the origin point of our component. The origin point value is G01, X0, Z0. At this point, the tool touches the workpiece. That's why we activate the slow feed linear motion code. Next, go to the arc start point. It is the P2 point. We don't know the arc starting diameter value. How that arc starting diameter value, we will calculate. It is calculated based on the arc radius value and arc endpoint value. The arc radius value is mentioned in the drawing. That arc radius value is R2. R means radius. Now I will create one circle. That circle radius is 2 mm. In these arcs, which one is suitable for our arc? First arc is the suitable arc for our arc. This is the center point of the circle. From this point to the arc start point, length is 2. This is also 2. 2 is the radial value, but we are writing the program diametrically. That's why that radial value is converted diametrically. 2 into 2 equals 4. With this 4, we can calculate the arc starting diameter value. The arc ending diameter value is -4. The arc ending x value is 30. 30 minus 4 equals 26. It is the arc starting diameter x value. Before writing the point, check the which type of motion from P1 to P2. It is the linear motion. This motion code is G01. The P2 point value is G01, X26, Z0. Next, go to the P3 point. It is the arc endpoint. Now check the direction of the arc. How to check the direction of the arc? It is based on the arc starting point to end point direction. Now our arc direction is anticlockwise. Up to now, we are using the G01 code, because those points are linear motion. But at this point, circular motion in the anti-clockwise direction. This motion code is G03. The P3 point value is G03, X30, Z-2, CR equals 2. CR means circular radius. Our arc radius value is 2. Without radius values, we can't create arcs or circles. That's why I define the CR value. Next, go to the P4 point. This point motion is linear motion. We activate the G01 code. This point value is G01, X30, Z-25. Next, go to P5 point. At this point also we don't know the x value. How to calculate the x value? We already discussed in the P2 point on how to calculate the x value. Follow the same process and calculate the x value. I will draw one circle. This circle radius value is 3. This arc is suitable for our arc. This is the center point of the circle. From this point to the arc start point, length is 3. This is also 3. 3 is the radial value, but we are writing the program diametrically. That's why that radial value is converted diametrically. 3 into 2 equals 6. With this 6, we can calculate the arc starting diameter value. The arc ending diameter value is -6. The arc ending x value is 60. 60 minus 6 equals 54. It is the arc starting diameter x value. The P5 point value is G01, x54, z minus 25. The next point is the P6 point. It is the arc endpoint. Now check the direction of the arc. How to check the direction of the arc? It is based on the arc starting point to endpoint direction. Now our arc direction is anticlockwise. Up to now, we are using the G01 code, because those points are linear motion. But at this point motion is circular motion in the anti-clockwise direction. The motion code is G03. The P6 point value is G03, x60, z minus 28. CR equals 3. CR means circular radius. Our arc radius value is 3. Without radius values, we can't create arcs or circles. That's why I define the CR value. Next, go to the P7 point. At this point, change the motion from circular to linear. Because this point motion is linear motion. That point value is G01, x60, z minus 50. Next P8 point. That point value is G01, x80, z minus 50. Next, P9 is the last point. That point value is G01, x80, z minus 75. This is the first method of radius programming. Now we will discuss one more method of the radius program. The second method point values are also the same, but in this method, CR place, we will replace the I and K values. What are the I and K parameters? I is related to the x-axis. K is related to the z-axis. Let's start the discussion of the points. The first point value is G01, x0, z0. The second point value is G01, x26, z0. Third point value is G03, x30, z-2. I don't define the CR value here. In this method, here we require I value and K value. This arc I draw here for calculation of I and K values. This is the radius start point, value is x26, z0. And this is the radius endpoint, value is x30, z-2. This is the center point of the radius. From the start point of the radius to the center point of the radius, the x value is the same. There is no change in x value. That's why we define the I value as 0. Next, check the z value. From the start point of the radius to the center point of the radius, there is a change in the z value. How much is the difference between the z values? The difference in the z value is -2 mm. That's why we define the K value as -2. This is the process of the I and K values calculations. Next point is the fourth point. That point value is G01, x30, z-25. The fifth point value is G01, x54, z-25. Sixth point value is G03, x60, z-28. In this method, here we require I value and K value. We already discussed how to calculate those values. Same process, we will calculate the I and K values. This arc I will draw here. This is the radius start point, value is x54, z-25. And this is the radius endpoint, value is x60, z-28. This is the center point of the radius. From the start point of the radius to the center point of the radius, the x value is the same. There is no change in x value. That's why we define the I value as 0. Next, check the z value. From the start point of the radius to the center point of the radius, there is a change in the Z value. How much is the difference between the Z values? The difference in the Z value is minus 3 millimeters. That's why we define the K value as minus 3. Next point value is G01, x60, Z minus 50. The eighth point value is G01, x80, Z minus 50. The last point value is G01, x80, Z minus 75. This is the second method of the radius programming. These are the shaper values. What is our program structure? Our program structure is a header, shaper, and footer. We know the shaper values. Header and footer, which we will add on the software. Next, move on to the software. Double-click on the software. Select the machine and start the simulator. Adjust the speed override and feed override. The machine required a reference. Click on X plus and Z plus. Next, go to the Program Manager for new program creation purposes. Click on the New. Type the program name is Radius. Click on OK. The new file is opened. Start the program. The program starts with a header. G90. Absolute dimensioning. G71. Program data in mm. G18. ZX working plane. G95. Feed in millimeter per minute. G64. The continuous path on. G40. Tool radius compensation cancel. Next. G75, X0, Z0. Return to the home position. Next, activate the tool. T01. D1. M06, automatic tool change at home position. Next, activate the spindle. G96. Constant cutting speed on. M03. Clockwise direction. S300. Cutting speed. LIMS equals 1500. Maximum RPM. Next, safety point. G00. X82. Z2. Next, M08. Coolant on. Next, shaper. Now I will go with the first method. G01. X0. Z0. F0.15. Linear interpolation in slow feed motion. At this point, the tool touches the workpiece. Next, G01. X26. Z0. Next, G03. X30. Z-2. CR equals 2. Next, G01. X30. Z-25. Next, G01. X54. Z-25. Next, G03. X60. Z-28. CR equals 3. Next, G01. X60. Z-50. Next, G01. X80. Z-50. Next, G01. X80. Z-75. Next, footer. Next, return to the safety point. G00. X82. Z2. Next, spindle stop and coolant off. M05 and M09. Next, return to the home position. G75. X0. Z0. Next, M30. Program end and reset. Next, click on the renumber. Blocks are provided with the sequence numbers. Go to the offset and check the tool. Next, go to the program. Now, go to the simulation. Activate the auto mode. Next, Click on the cycle start. This is the tool path of our program. Click on the delete window. Now, we will go through the material simulation. Go to the More. Click Material Removal. Add the raw material length and diameter. Our raw material length is 75 mm and our diameter is 80 mm. Click on Save. Adjust the raw material in the center of the controller display. Click on Cycle Start. Now, we check the values. The radius length is 2 mm. Next, check the radius starting diameter. 13 is the radial value. 26 is the diameter. Check the second radius values also. This is the first method of radius programming. Let's go to the second method of radius programming. Go to the Edit. Here, simply we will change the CR values. That is the second method. Go to this block. Delete the CR value, and we will write the I0 K-2. Now, go to this block. Delete CR value, and we will write the I0 K-3. Now, go to the simulation. Click on the delete window. Adjust the raw material in the center of the controller display. Next, click on the cycle start. Check the values.